You know how you tap a button on your phone and just like that, you can buy or sell a piece of a company? It really does feel like magic. But behind that super simple screen, there's this massive, incredibly complex engineering system where every single millisecond counts. So today, we're going to pull back the curtain and see how these stock trading apps are actually built.
I mean, seriously, have you ever just stopped and thought about what's happening under the hood when you check a stock price? It's not just a simple app. It's this high-stakes digital ballet of data, security, and pure speed, all designed to give you perfectly accurate information right now. And at the heart of it all, it really comes down to three pillars. You've got real-time speed, ironclad security, and constant, always-on data. These are the absolute non-negotiables. You just can't mess these up. If you get even one of these wrong, the whole system is at risk. So the real challenge for engineers is mastering all three at the same time.
Okay, let's dive into the blueprint. You know, with any huge project like this, the first step isn't to just start writing code. It's to ask a really simple question. What exactly are we building?
So what are we talking about here? Well, the essential features are probably exactly what you'd guess. You've got to be able to see your portfolio with live prices. That's a given. You obviously need to buy and sell stocks, analyze all that historical data with charts, and get those crucial price alerts with notifications. That's our foundation.
In this foundation, it needs to be rock solid. Why? Because this isn't being built for just a few dozen people. The target here is to handle 500,000 daily active users. And that kind of scale, it changes every single decision you make from here on out.
And serving that many people means you have to get data to them, and fast. So the next critical question is, how does the app get all the information it needs? This is all about setting up the right communication lines between your phone and the entire financial market.
Yeah, the app has to do two totally different things at once. It needs to ask for specific info on your command, but it also needs to receive this constant, never-ending stream of live updates. So how does it do that? One method, or maybe two.
Okay, now this is where it gets really clever. They use a hybrid approach. For those on-demand things, like say checking your portfolio balance or placing an order, the system uses what's called a REST API. The analogy here is perfect. It's like ordering from a menu. You ask for something, the server brings it to you. Simple. But for live stock prices, you can't keep asking every millisecond. That would be crazy. That's where WebSockets come in. Think of it like an open phone line where the server can just push updates to you instantly without you even having to ask.
So with those communication lines figured out, it's time to actually design the structure of the system. And listen, when you're dealing with people's money, that structure can't just be some simple house. It has to be a digital fortress.
And every fortress needs a gatekeeper, right? Well, the best way to think about the first line of defense is exactly that. The entire system needs a bouncer at the front door, checking every single request before it's allowed to come inside.
And this bouncer, which we call an API gateway, is doing a ton of work. It's handling all the security and authentication. It's managing traffic like a traffic cop to make sure the backend services don't get completely overwhelmed. It's validating every request to make sure it's legit. And it's monitoring everything for errors. Basically, nothing gets to the core system without passing this bouncer first.
Now, behind that gateway, the app's code isn't just a big, messy pile. No, it's neatly organized into layers. You've got the UI layer, that's everything you see and touch. Then there's the data layer, which manages all the business logic. And finally, the external services that power the back end. And separating things like this is so important because it means engineers can update one part, like the user interface, without accidentally breaking the core logic that handles your money. It makes the whole system way more stable and easier to improve over time.
All right, now for the really cool part. Let's talk about how all this tech comes together to do something visually amazing, making market data literally dance on a chart on your screen. I mean, really think about that for a second. A 5-year chart for a single stock could have thousands of data points. How on earth do you render all of that incredibly dense information on a small mobile screen without the app just slowing to a crawl or, worse, just crashing completely?
So engineers have a few choices here, and each one has its pros and cons. They could use the phone's native graphics, which would give them the absolute best performance, but man, it's incredibly complex to build. Or they could use third-party libraries, which is way quicker, but you might take a performance hit. A really common solution is something called web view rendering, which basically runs a tiny web browser inside the app just to display the chart. And the big win there is you get great consistency across different phones.
Okay, so that handles the historical data.
But displaying live intraday charts, that's a whole other beast. Prices can change multiple times a second. How do you possibly keep up with that? And the solution here is just so smart. Instead of trying to redraw the chart with every single tiny price tick, which would absolutely destroy your phone's processor, the app uses what are called buffered updates. So first, it collects all the live price ticks as they come in from the server. Then, it batches them all together in a temporary holding area, kind of like a buffer. And finally, it updates the chart just once per second with that entire batch of data all at once.
And what you get is the best of both worlds. The chart feels like it's updating in perfect real time, giving you this super smooth visualization, but it's all done in an incredibly efficient way that doesn't overwhelm your phone or just drain your battery. It's brilliant.
So, when you take a step back and look at this whole system, what's the big theme here? Well, it all comes down to a really sophisticated engineering balancing act.
Let's just quickly recap the key principles we saw in action. First, using those hybrid communication protocols, the right tool for the right job, with REST and WebSockets. Second, protecting the entire system with that single secure API gateway. Third, keeping the code organized and clean with that layered architecture. And finally, balancing that real-time feel with your phone's performance using those clever buffered updates.
And at the end of the day, every single decision comes back to this. It's a constant series of trade-offs between making the app feel incredibly responsive, being efficient with your phone's resources, and creating the best possible user experience.
And all this just leaves you with a fascinating question, right? As data gets even faster and our expectations for real-time interaction just get higher and higher, what kind of new engineering challenges and what kind of brilliant new solutions will the next generation of these apps bring?